This is the tutorial for Chapter 11, Section 1, Day number 2. And so we're going to still continue to see some simplifying of expressions, and that's what this chapter is about. And we're going to also state the excluded values. So let's just go over that concept once more. So the key is to look for common factors. And so that's what, I don't see any common factors here. Even though you see the 16 and the 4 and the y squared and the y, this will end up reducing some, but in reality we need to factor the numerator and factor the denominator in order to cancel to get things right. So I see that the numerator is a difference of squares. So I'm going to rewrite this as y minus 4 and a y plus 4. And then down below, you see it's a 4 minus y. And we had talked about one problem like this on the last lesson, where this is just not quite the same as y minus 4. Both signs are opposite. And so what I'm going to do is I'm going to take out a negative 1. And when I do that, then the signs will switch. The y will become positive, the 4 will become negative, and now we can go ahead and reduce the y minus 4. And so what's left over? Well, we still have the y plus 4, but over negative 1. So typically what they're going to end up doing is rewriting this as one of two ways. They could either write it as negative 1 times by y plus 4, like this, and because basically you're dividing negative 1 into that, and it would switch the signs of both parts of the numerator, or you could just write it as negative y minus 4. So either way I would take as a good answer. Even this one is fine. So this next problem, we have the same situation where you see how the variable term is last and it's negative. Here, the variable term is first and it's positive. So that tells me I'm probably going to have to factor out a negative 3 to get things to cancel. So I'm going to go ahead and do that right now. And when I do that, I'm going to put the variable term first. So I'm dividing it by negative 3, and I'm left with 3d, and then a minus 1. Minus 1 because 3 over negative 3 makes negative 1. Down below, it's a trinomial that will factor as two binomials. So 3d and 2d multiply to make 6d squared. I'm pretty sure I break that down because here I have 1 as the last term, and I need the outside and inside terms to subtract to make 1, and that's what I have here. So 3d and 1 make 3d, 1 and 2d make 2d. So in order to make it a positive 1 when I go ahead and subtract, I'm going to make the 3 positive, the 2 negative. And now I can go ahead and reduce. So I do see the 3d minus 1's reducing, and that's all I can do. So I'll go ahead and rewrite the answer as just negative 3 all over 2d plus 1. Well, looking at this next one, I have the same situation. See, the z term is negative. Here the z term is positive, so I'm pretty sure I'm going to take out a negative 3. So I'll go ahead and do that. I'll switch the z onto the other side of the 3 here, so it's going to become a positive z and a negative 1. When I divide 3 by negative 3, negative 1, negative 3z by negative 3 just makes a positive z. Here I'll take out the common factor of 2, and when I do that, I've got z squared minus 1. Not the same, but this is a difference of squares, so it can factor once more. So I'm going to just factor it down here. And I'm going to factor it to a z minus 1z plus 1. I'll cross this one off since I've just factored it, and now I'll look for common factors on top and bottom. So z minus 1's will cancel, but that's it. That's all I can do. So we can go ahead and rewrite this as negative 3 all over, and then I've got 2 times by z plus 1. So you could write it this way. You might see it this way as well, negative 3 over 2z plus 2. Somebody, when they're coming up with the answers, might end up multiplying it out. So either way would be fine. Let's take a look at the next problem. Here we've got a couple word problems, and it says that in the figure at right, what is the ratio? Okay, ratio of area of the shaded triangle to, okay, so right there, that tells us the fraction right there. So ratios are fractions. They're comparison of two numbers. And so we're going to put the area of the shaded, area of triangle, I'll say, over the area of the rectangle. Area of the rectangle. And so when you see the word 2, that kind of signifies our fraction bar here. What they mention first goes on top, what they mention second goes on the bottom. It's important to make sure we get it set up the right way, otherwise the reducing would be incorrect. So it says, what is the expression for the length of the rectangle? So let's go ahead and look at the length here as x and 8 for the rectangle, And now they're saying, how do you find the area of the triangle? So they're just giving us some hints on this problem. So basically, let's start with the triangle. And the area of a triangle is 1/2, this is the triangle here, 1/2 base times height, where the area of the rectangle is just base times height. So let's start with the area of the triangle. So we've got 1/2 the base, which is x, times the height. Now the height ends up being x as well, because you see it goes from the top to the bottom. That makes a right angle, and that would represent the height, and that is x. So I can rewrite that as 1/2 x squared. Now on the area of the rectangle, we've got an x by x plus 8. So x, write it down here, x times x plus 8. So I've got the x and the x plus 8. Now rather than multiplying at this stage, though, I'm going to leave it in this factored form because I see some common factors I can reduce. So you see how this x will take away one of the x's on top of the fraction, just leaving me with the 1/2 x all over x plus 8. Now, typically we don't like to have an expression with a fraction and in a fraction, so that's not quite reduced. And so what we can do is we're dividing by 2. So to show that dividing by 2, that's what the fraction means, we can do this. We can write this as x over 2 times by x plus 8. So basically I just took this 2, and since fractions are a multiplication of the numerator divide by the denominator, I just moved this 2 into the denominator, and that means divide. So that would be our expression right there. Now, let's go ahead and state the excluded values that we could not have for x. So x cannot equal 0, and that makes sense. You can't have a length of 0. And x cannot equal 8, or negative 8, because negative 8 plus 8 would make 0. So those are the two excluded values that we cannot have for x. So here we're supposed to write a ratio in simplified form of the area of the shaded figure to, okay, so there's the fraction bar. So we got the shaded figure, shaded to the area of the enclosed, the figure that encloses it. So basically the trapezoid. Trapezoid. So let's start with the area of the shaded figure. That ends up being, we'll say it's just 5w times by 5w. It's a square because all sides are the same. We know this is 5w, we know this is 5w. That tells us that this is going to be 5w and this is 5w as well. So it ends up being a square. Let's take a look at the area of the trapezoid. It's 1/2 the height. Well, the height is 5w times by the sum of the bases. So we've got to add this base right here. So that's going to be 6 plus 5w plus 6. That was this first base here. And then we're going to add on this side right here, which is 5w. So we have to add on another 5w. So from this point, we can go ahead and simplify this a little bit. We can go ahead and multiply that out. 25w squared, just makes it a little bit smaller. Here we need to add this material together first. So we've still got this 1/2 5w. And here we multiply or add some like terms. We have a 12 plus 10w. So what I can do is I can take out a common factor from the 12 and the 10w. So I'll go ahead and do that. So I still have the 25w squared. I got the 1/2, the 5w. And now I'm going to multiply by 2, and then I've got the 6 plus 5w. Well, I wasn't able to reduce the 6 plus 5w, but this did help me out because I do see that this 2 will cancel out this 1/2. And now this w here will take away one of the w's on top, and 5 goes into 25 5 times. So sometimes when you start canceling a lot of stuff out like that, I find it easier, or I'll make less mistakes if I circle the parts that are left over. So I look at that, I circle those parts that are left over, so that way I don't forget about anything. I've got 5w on top, And the only thing, see, all these are crossed out, so the only thing left is this. And then I'll look again. Okay, everything's crossed out. This is all that's left. So I'll write 6 plus 5w. Now, don't think you can go ahead and reduce those 5w's. You can't, because it's not really 5w on the bottom of the fraction. It's actually 6 more than 5w. So sometimes people would want you to write it with the 5w first on the bottom of the fraction. So if you do that, either one would be good. So that is the ratio of the shaded figure to the figure that encloses it. Well, those are the types of problems you're going to see on today's assignment. Good luck.